Welcome to Unit 7, Lesson 6, Probability with Permutations and Combinations. So a real quick recall that a permutation is an arrangement or lineup of objects in which the order matters. And a combination is a grouping of objects in which the order does not matter. Okay, so remember, permutations are whenever you can line them up, put them in some kind of arrangement where there is a specific order. It doesn't have to be first, second, third, but it has to have an order to it. For example, if I put books on a shelf, right, as I'm putting them on the shelf, I put one on the left and then I put one next to it, put one next to that. That's an order. If we're talking about vacation lengths, you have a vacation that's longer or shorter. If you're talking about, let's say, leaders, right, like a president, a vice president, a treasurer, things like that. Those all have an order to them. Where combination, right, is just a group of objects. They're not in a specific line. They're not in a specific arrangement. It's just a group of objects. There's two formulas, right? One for the permutation, one for combination. And I'm going to show you the shortcut of how to put this into the calculator. Of course, this is the calculator we use in class. It will work in other similar calculators, I'm sure. And there are actually ways to do these calculations on a line as well. There's different types of permutation and combination calculators that you can find if you search them up. Okay, so real quick reminder, we have two pieces of information whenever we're trying to figure out permutations and combinations in terms of finding the total, right? Like the total number of outcomes. So N is the total number of objects in your scenario, and then R is the number of objects being chosen for that specific situation. All right, so now bringing in probability. So when we first talked about probability, we talked about the fact that the probability of an event E occurring, so P parentheses E, is the desired outcomes over the total outcomes. And so it's a ratio. A lot of times we write it as a decimal or a percent as well. Today, I just want to focus on the ratio as a simplified fraction because some of these probabilities are going to be so small that if you try to change it to a percent in the calculator, it's not going to be able to do that calculation. So we'll just leave them as simplified fractions. All right, so here we go. Example 1. It says a 4-digit passcode was created randomly using the digits 0 to 9 with no repeating digits. Find each probability. And then it gives us A, B, C, and D for the probabilities that we need to look for. So before even looking at the probabilities, we need to look at the scenario and decide, is this a permutation scenario or a combination? And then we need to figure out what are the total outcomes in that scenario. So if it's a passcode, it means that the order matters, right? Whenever you have a passcode, a password, anything like that, the order matters. So that's a permutation. N is the total number of digits that are available, which is the digits 0 to 9, and there are 10 of them. Whereas R is going to be the ones we're going to use, which is going to be 4 because it's a 4-digit passcode. And so our total number of outcomes is going to be 10 permutation 4. Okay, that's going to be our total. And that's going to be for this entire scenario. So since there are 4 parts, we're going to use that total for all 4. All right, so for part A, let's take a look. It says the passcode is 0123. So let's think about our desired outcome, right? We already have the total anyways. We just need to figure out what the numerator is going to be. We just need to figure out what our desired outcome really is. How many outcomes are in those desired outcomes? Okay, so if the passcode is 0123, thinking about the scenario, there's only one way to get a 0 in the first spot, a 1 in the second spot, a 2 in the third spot, and a 3 in the fourth spot. Right? There's only one way for this to happen. So that means there's only one desired outcome that can possibly happen that can make the passcode exactly 0123. So that means that our probability is going to be 1 over the total number of outcomes, which is 10 permutation 4. Now the shortcut in the calculator that I don't believe I showed you in the last note, so I want to make sure that you see this. I'm going to show you how to do this in the calculator. So you're going to go to math, which is under alpha. You're going to go over to prob. And you can do permutations, combinations, you can do factorial, any of that you need. So I'm going to do the permutation, push enter, and I'm going to do 10 permutation and slide over to do 4. And it's going to calculate it for me, so I don't have to use the formula. So that's 5040. Perfect. So now I'm going to write this as 1 over 5040. Which is not going to simplify, and we're not going to worry about getting a percent. We're just going to leave it that way. So the probability of getting a passcode of exactly 0123 is not very likely. It's 1 out of 5,040 options. Okay, perfect. All right, next. Hold on, let me rewrite this real quick. Now we can look at B. B says 4 is not in the passcode. Okay, so the desired outcome is that 4 is not in the passcode. Well, in the digits 0 to 9, if I take out 4, okay, so take this out, that's going to leave us with an N of 9 left. So instead of 10 total digits, we're going to have 9 left because we're not going to use 4. But we still have to choose 4 digits, right? So the N has changed, right? N is 9, but the R has not changed. It is still 4. So now for our desired outcome, it's not going to be 10 permutation 4. It's going to be 9 permutation 4. But our total is still 10 permutation 4. So the desired outcome, 9 permutation 4 over the total, is going to give us that probability. So in the calculator, I'm just going to go ahead and calculate that. So I'm going to go ahead and calculate the 9 permutation 4. Keep in mind the 10 permutation 4 is already done, so we don't need to worry about it at all. So the top one is going to give me 3024. The bottom is going to give me 5040. And then you can simplify this either by hand or in the calculator. You're going to get 3/5 when you simplify that. So that's our probability, which that's a pretty easy one to turn to a percent. That's 60%, but I'll just leave it as a fraction. All right, let's look at C. So the passcode begins with an 8. Cool. So there's a 4-digit passcode. Now we know that it begins with an 8. So let's just draw what this is going to look like. So we have a 4-digit passcode, and we know it's going to begin with 8. So that means the first number is going to be 8. So we have no choice in that matter, right? What's the probability that the first one is 8? That's basically locked in. Okay, there's nothing we can do to change that. Only thing that we now have to look at is what the second, third, and fourth would be. So now there's only 3 spots open, right? 3 slots open that we can put a digit in. And it can't be 8 because it said that there's no repeating digits. So that 8 is gone. So looking at the scenario that way, the desired outcomes, there's only going to be 9 numbers because 8 is already used, right? 8 is here. So there's only 9 numbers left. And then the R, instead of choosing 4, we can only choose 3. We can only choose the 3 slots, okay, that are remaining. So that's what R is going to be. So for our numerator, for our desired outcomes, it's going to be 9 permutation 3, but it's still 10 permutation 4 for our denominator. So the denominator is still 5040. Go ahead and do the other one, and that's a 504 when I do that one in the calculator. And we're going to simplify that to 1/10, and that is our probability. All right, let's take a look at this other one. D, the passcode starts with no more than 3. Cool. So the passcode starts with no more than 3. No more than 3. What does that mean? What are those desired outcomes? No more than 3 means it could be 3, but it can't be more. So it could go down. It could be 2 or 1 or 0, right? Those are our options. So there's 4 options there. 4 options there. Now let's look at this visually. So there could be a passcode that's a 3 and then there's 3 digits we don't know. Or it could start with a 2 and then 3 digits. And then similarly, it can start with a 1 and then 3 digits. Or it could start with a 0 and then the same, right? 3 digits. So kind of like the last one, those are locked in, right? I can't change what those first digits are, but there's now 4 ways that it can happen. So there's 4 options here. But for all 4 options, no matter which one, you do not have 10 numbers to choose from. You only have 9. So N is 9, okay? Because I can't choose the number that I've already chosen, right? No matter which one of these it is, I can't choose that one again, okay? And so I have 1 less to choose from. My R is the same for all of them because I have 3 slots to fill. So that's 3. Okay, those are the ones I have to choose. I have to choose 3 numbers. Okay, so now when you do the shift, be very careful. Instead of it just being 9 permutation 3 like it was for the last problem, it's that 1, 2, 3, 4 times. So times 4. So it's going to be 4 times 9 permutation 3 over 10 permutation 4, which is the total that's been for the entire problem, right? That's not going to change. So for the numerator, if I do 4 times 9 permutation 3 in the calculator, you're going to get 2016. And then for the denominator, it's going to be 5040. Simplify that, and you're going to get 2/5. So that's the probability that it starts with something that is no more than 3, which is 3, 2, 1, or 0. Perfect. All right, let's continue on. So for example 2, it says Lexi is taking 6 classes each day next semester. If her schedule is randomly created, what is the probability that she has math first period and science second period? First of all, when we figure out if it's a permutation or a combination, and when we figure out the total outcomes that are possible, we have to ignore the probability question itself. So Lexi is taking 6 classes. If her schedule is randomly created, that's the only thing we can use. Okay, we can't talk about the probability part yet. This part we cannot talk about yet. So determining permutation or combination, we think about how schedules work. Is there an order to it? Of course, there's first period, there's second period, there's third period, right? So there's going to be an order to that. So that means it's a permutation for sure. So this is a permutation. Okay, now still ignoring the probability part, ignoring that. Let's figure out what N and R are. Okay, so N is the total number of options. How many classes is she taking, right? So there's 6 classes. What about R? Does she have to choose all 6 classes or can she choose less? Well, based on what it's saying, she's taking 6 of them. So she has to choose all 6 classes. She has to fill that schedule, right? This isn't like a senior in high school who can have open periods, right? This is a person filling the entire schedule with 6 classes. So N is 6 and R is 6. So for the total, we're looking at 6 permutation 6. Okay, now we just got to look at the probability part to figure out the desired outcomes, and then we can do our fraction, okay, our ratio. All right, so now what is the probability that she has math first period and science second period? Well, let's just make a little diagram, right, of what the schedule might look like. So we have first period, second period, third period, fourth period, fifth period, sixth period. What we know is that her schedule is randomly created, but we want the probability that math goes in first period. So I'll put math there. And then science is in second period. So I'll put that there. We don't know anything else about what the other classes are going to be. So these two are locked in. We can't do anything about math and science, right? We want the probability that those are exactly in that spot. The only ones that we are unsure of is the other 4. Okay, so there's 4 classes that we still need to fill. So N is 4, and we have to fill all of them, right? So R is also 4. So now we have for our desired outcome 4 permutation 4. For our total was the 6 permutation 6. Put these in the calculator, and you're going to end up with 24 over 720, which is equal to 1/30. And that's it for that one. All right, let's look at the next one. Example 3, the letters in the word orange are randomly rearranged. What is the probability that the letters are in alphabetical order? Okay, ignore everything that talks about probability. So ignore the entire second sentence. All I want you to look at is the scenario. So the letters in the word orange are randomly rearranged. Is there an order to that? When you take letters that are in a word and you arrange them, is there an order to that? Okay, the answer is always going to be yes, when it talks about rearranging them like that. Because if I have the word orange, right, I have a first letter, I have a second letter, a third letter, a fourth letter, and so on. So this is a permutation. Okay, ignoring the probability part, our N, our total that we have to choose from, is how many letters are in orange. 1, 2, 3, 4, 5, 6. So that's 6. And our R is also 6 because it says we're rearranging the letters, right? It doesn't say we're ignoring any of them. So R is also 6. So we are rearranging those letters, all of the letters. Okay, so for our total, it's actually going to be the same as the total in the last problem, 6P6. Okay. All right, now let's take a look at the actual probability. So what is the probability that the letters are in alphabetical order? Well, I'm going to draw a diagram of this, but I think for a lot of you, it's going to be kind of obvious, okay? So we have 6 letters, 1, 2, 3, 4, 5, 6, and we're going to put them in alphabetical order. So, for example, in orange, this letter that comes first in alphabetical order is A, then it's going to be E, then G, N, then O, then R, okay? So if we put those in alphabetical order, you can see visually there's only one way to do that. There's only one way that that is possible, okay? So putting something in alphabetical order, there's only one way to do it. Now, if there was repeating letters, then it might get more complicated, but since they're all different, it's one way, okay? So that means the numerator is 1. Our denominator is the total, which is 6P6, which in the last problem we know is 720, so it's 1 over 720, which cannot simplify, so that is the answer. All right, now let's look at this next one. All right, so this next one says there are 12 books on the shelf, all with different heights. If 3 books are chosen at random, what is the probability that one of the books chosen is the tallest book on the shelf? Okay, so in our scenario, we have to ignore everything that talks about probability. So that's that question. What is the probability? Ignore all that. Just look at the scenario. So there's 12 books on a shelf, all with different heights. If 3 books are chosen at random. So think of the scenario itself. When we are arranging or grouping these books, is there an order to it or is there not? So it says if 3 books are chosen at random, and that's all it says. right? We're not putting the books on the shelf in an order. We're taking them off at random. So it doesn't say that we're putting them in an order or anything like that. So because of the way it's written, right? If 3 books are chosen at random, this is actually going to be a combination. For all we know, we're just setting those books down in no particular order. That's it, okay? So now we can look at the probability itself. Well, actually, let's do our total first. So N, right, to choose from is going to be 12 books. And the R is going to be 3 because we're choosing 3 at random. So for our total, it's going to be 12 combination 3. Okay. Now we can look at the probability. What is the probability that one of the books chosen is the tallest book on the shelf? Okay. So I'm just going to draw a little diagram. Instead of doing it like this in order, since it's not permutation, I'm just going to do it as if it was just a little group, like a little bubble. So I'm just going to do a circle, and I'm going to put 3 books in there. Okay, these rectangles are going to stand for books. So there's 3 books in there in no particular order. What is the probability that one of the books is the tallest? So I'm going to go ahead and write T for tallest on one of those books. But I don't know anything about the other 2 books. Okay, so now let's think about the desired outcome. How many ways can that happen? Where we know one of them is the tallest and the other 2 we don't know anything about them. Well, if we know one is the tallest, that's locked in. We can't do anything about this. We have to ignore that one. That one's locked in. So that means that we only have 2 books that we can actually choose from. So that definitely tells us that for the desired outcome, our R is only 2. Okay, our R is only 2. But if we have to ignore that tallest book, then our N is not 12 anymore. We have to take one away. It is now 11. Okay, so for the numerator, we're going to have 11 combination 2. Okay, and for our denominator, for the total, it's going to be 12 combination 3. So again, if we know one of them is the tallest, we have to ignore that book, which not only takes our total down to 11, but then it means we're only choosing the other 2, and that's going to be ours too. All right, so now put these in your calculator, and you will get that 11C2 is 55, and that 12C3 is 220. If you simplify that, you do get 1 over 4. Okay, you get 1 over 4. Perfect. Okay, let's look at the next one. We're almost done here. Example 5. There are 28 girls and 21 boys in the choir. If 2 are chosen at random to sing a duet, what is the probability that at least one is a girl? Okay, ignoring the probability question. Let's look at the scenario. There's 28 girls and 21 boys in choir. If 2 are chosen at random to sing a duet, what is that? Okay, is that permutation or combination? Well, 2 are chosen at random. It doesn't say there's any specific title to the 2 that are chosen, no order to it, so that's definitely going to be a combination. Okay, so for our total, we're looking at, let me write it this way. Let me write the N and R first. Getting ahead of myself. So N, the total, is going to be 28 plus 21. So N is 28 plus 21, which is 49. And then my R is going to be the 2 that are chosen at random. And then my total, go ahead and put that down here, is going to be 49 combination 2. Okay. Now, I want you to be really, really careful with this. I'm going to show you the easiest way that I know of to answer this question. So what is the probability that at least one is a girl? That at least one is a girl. So because it says at least, that means that there's not just one specific answer, right? At least one is a girl means there's 1 girl, or there could be 2 girls, right? It just means that there's no way to have only boys, right? Is basically what it says. Okay. So the fastest and easiest way that I know to do this is to use complements. Okay. Remember, complements are basically using everything that's not in the scenario, right? Not in the set when we did it with sets. And so the complement of at least 1 girl means that there's no girls at all. So if there's no girls at all, then there's boys. There's only boys. So it's going to be much easier to find the probability of this. And then what you'll do to find the actual answer is you'll do 1 minus your complement. Okay, we learned this first in the intro lesson. Okay, intro to probability, which was lesson 2. Unit 7, lesson 2, if you want to go back and look at that. So only boys. So for only boys, we have that N is going to be the amount of boys, which is 21. And we are choosing 2 of them for the duet, so R is still 2. Okay, so we're going to do 1 minus. And then for our numerator, it's going to be 21 combination 2. looking at only the boys. For our denominator, it is going to be our 49 combination 2, looking at everybody, all the possible outcomes, right, from the whole class. So you can do this straight into the calculator, but we can do it in pieces. So we can do 1 minus, and we can do 21C2, which is 210, over 49C2, which is 1176. You can either type this straight into a calculator, or you can do like terms. You can get you can do 1176 over 1176, and then you can subtract 210 and then simplify from there. No matter how you do it, you're going to end up with 23 over 28 eventually. And there's our simplified answer. All right, keep going. Example 6. Jalen is deciding on what order to visit France, Italy, Spain, England, Germany, and Ireland within, sorry, typo, the next 2 years. If he randomly chooses the order, what is the probability that he visits Spain first? Okay, perfect. So ignoring the probability part for a second, right? Let's look at the scenario. Jalen is deciding on what order to visit France, Italy, Spain, England, Germany, and Ireland within the next 2 years. So it already says it right in that scenario that we want the order that he's going to visit them. Which one is he going to go to first, second, third? So that's for sure a permutation because the order matters. Okay, permutation where n is equal to France, Italy, Spain, England, Germany, and Ireland, which is 6 options. So there's 6 countries he wants to go to. And assuming that in the next 2 years he's going to visit all of them, then of course R is also 6, right? So based on this scenario, we are talking about 6 countries he wants to visit, and we're talking about him going to all 6. So N and R are both 6. Okay, it says if he randomly chooses, let's write the total out, my bad. Let's write the total out first. So total for the denominator is going to be 6 permutation 6. 6 permutation 6. And then we're going to look at the actual probability. What's the probability that he visits Spain first? Okay, so I'm going to draw a little diagram again. So 6 countries, 1, 2, 3, 4, 5, 6. He's going to go to one country first, then the next country second, third, and so on, okay? So looking at this, if we are talking about the probability that Spain is first, then we know that Spain is in this first slot, but we don't know anything about the rest of the slots. So because we don't know anything about the rest of the slots, there's still 5 slots to fill. So N is 5. And he has to fill all 5 slots, so R is 5. So for our numerator, right, for our desired outcomes, it's going to be 5 combination 5. Oh, not combination, excuse me. It's still permutation because the order matters. Permutation 5. And then 6 permutation 6 for the denominator. We know the denominator is 720 because we did that earlier. 5 permutation 5 is 120. Simplify that and you get 1/6. 1/6. All right, last one. Example 7. There are 4 freshmen, 7 sophomores, 6 junior, and 3 senior flute players in the marching band. If 2 are chosen at random to lead the practice, find each probability. So ignoring the probabilities right now, we're just going to look at the scenario. So there's 4 freshmen, 7 sophomores, 6 junior, 3 senior flute players in the marching band. If 2 are chosen at random to lead practice. So there's no order to them being chosen. 2 are chosen at random to lead. There's no specific titles to what they're doing, right? It's not like president, vice president, anything like that, right? So that's going to be a combination. The order doesn't matter. So N is going to be the total. So 4 plus 7 plus 6 plus 3. That's going to be 20 total people. And R is going to be the 2 that are chosen at random, okay? So for that, the total is going to be 20 combination 2. All right, now let's look at all of our scenarios, all of our probabilities. So find each probability. Both are juniors. Okay, super easy. So the juniors in this situation there's 6 of them, right? So that's going to be, N is 6 for the amount of juniors, and R is going to be 2 because we're choosing 2 no matter what, right? That's what it says. 2 people are leading. Okay, so that's going to be 6C2 for the desired outcome, and then our total of 20C2 for our denominator, for our total. Put those in the calculator, you do get 15 over 190, and when we simplify that, we get 3 over 38. 3 over 38. All right, couple more. The next one says neither is a senior. So we're looking at neither is a senior. That's not too hard to find. We just take everything that's not a senior. So N, instead of being 20, we're going to do 20 minus the 3 senior flutes, and that's going to be 17. Okay, 17. R is still 2 because we're still choosing 2 for to lead the practice, right? So it's going to be 17 combination 2 for our desired, and still our total of 20 combination 2. Put these in our calculator, and we're going to get 136 over 190, which simplifies to 68 over 95. All right. C, one is a freshman and the other one is a sophomore. So let's be really careful with this one. We're going to almost look at this like compound probability. Okay. We're going to kind of look at it that way. So one is a freshman and the other is a sophomore. So for the freshman, okay, there are 4 freshmen. So that means N is 4 for that scenario, but we're only choosing 1 freshman. So R would be 1 for that one. The other option is that it's a sophomore. Okay, well, there are, according to the scenario, 7 sophomores. So N is 7, but we're only choosing 1 sophomore, and R is 1. So together, we have chosen 2, like we needed to, but we just did it separately. So when we do this one, we're just going to do those 2 individual combination outcomes, and we're going to multiply them together. So that's why I say it's like compound probability. So we can do the freshman, which is 4 combination 1, and then multiply that times the sophomores, which is 7 combination 1, and then over the total, which is still 20 combination 2. If we do all of that in the calculator, we do get 28 over 190, and simplify that to 14 over 95. Perfect. All right, last one. At least one is a sophomore. So again, this is sort of, if you just try to go at it head on, confusing, because at least one is a sophomore means you can have 1 sophomore or you could have 2 sophomores. So then it gets complicated. But if you remember from what we did earlier in the notes, at least means we can easily use the complement of that. So the complement of at least 1 sophomore is no sophomores at all. Okay, and now that's going to look a lot like the scenario where we said neither is a senior, right, above. So no sophomores at all means everybody else. No sophomores at all, meaning everybody else, is going to be 20 minus the sophomores, which is 7 of them. So we're going to now use an N of 13. We're still choosing 2 no matter what, so R is 2. But remember, when we do this probability, we have to do 1 minus our complement. So we have to do 1 minus the complement that we just found, right? And that will give us the probability of the actual scenario itself. So it's going to be 1 minus the complement. So it's going to be 1 minus the 13, choose 2, over the 20, choose 2. When we simplify that, the 2 combinations, we get 1 minus 78 over 190. And again, you can always do this by hand by getting that common denominator, 190 over 190, subtracting 190 minus 78, and then simplifying from there. But I can do the whole thing in the calculator, and I can get 56 over 95 as my simplified fraction, and I'm done. All right, thanks for watching, everyone. Have a great day.